Okay, guys, I think in the last video I had finished until here, and this problem I had to do. Okay, so I thought, okay, I'll substitute some values and do it, but since it's a 1 mark question, so we should be able to answer this in 1 mark only in one minute. So this much complication is not required. That's what I feel. So what we do is, yes, here we have asked about, there are two charges, 10 micro and minus 5 micro, which are present over here. And there are three positions being asked, and which of these positions is the electric field 0. Now, definitely at this point, if I consider, the electric field will not be 0. The reason is because you see, the electric field due to this charge, due to this positive charge, will be directed in this direction. Due to negative charge, it will attract it. So definitely net electric field here will be in this direction. So it is not 0. Now let us consider this point over here. At this point, if I keep a unit charge, this charge will be repelled away by this 10 micro and it will be attracted by this minus 5 micro. So if you ask me what will be the net force can be 0. Okay, can be 0. Now let us consider two cases. In position 1, it can be 0. It can be 0. It cannot be 0. It cannot be 0. Both the things are possible. Okay, it can be 0 depending upon the distance between the two charges. Now, when can it be 0? When cannot be 0? Okay, let us look at that also. See here, if I consider this position 1, the 10 microcoulomb will exert a larger force. While the minus 5 microcoulomb, which is farther away, will exert a smaller force. So from this we can realize that it can be 0 is incorrect. Okay, so it should be cannot be 0, should be the right one. So at position 1, it's not possible. Position 2, definitely not possible. At position 3, it could be possible. This is the only position which is possible. So position 3 is the right answer. Okay, I hope this is clear for you. Okay, then let us look at the next one. This is a problem on circuits. A cell of EMF 4 volt is connected to the 3 resistors. As shown in figure, the 2 resistors of resistance 2 ohms are connected in parallel and are in series with a resistor of 1 ohm resistor. Okay, what power is dissipated in one of the 2 ohm resistor and in the whole circuit? So he is asking you what is the total power and what is the power across the 2 ohm resistor. That's what we asked. Now we know that, see here, this is a parallel circuit, then this is connected in series. So as a result of it, it's a hybrid circuit. So what can happen now? We now need to find out what is the power here. Now, how do we find the power? If I want to find the power here, this would just be, okay, now I want to find P total here. Okay, so now you see here, power dissipated in 2 ohm resistor is given like this. Power dissipated in the whole circuit is given like this. Okay, so now towards it, if you want to find the whole circuit, then let us simplify the circuit. Now if I simplify, this becomes 2 parallel to 2 becomes 1. This will be 4 ohm. This will be 1 ohm over here. And this is once again 1 ohm. So the net answer would be 4 volt and this is 2 ohms. So you'll get a simplified circuit like this. You'll get it like this over here. So this will be 2 ohm. This is 4 volt. So as a result of it, if you ask me what is the power here, the power here P total would now be equal to V square divided by R. Okay, V square divided by R total, which should be equal to 4 square divided by 2, which should be 16 by 2, which is equal to 8 watts. Thus the total power is equal to 8 watts. Okay, now 8 watts, where is it? Okay, so it's over here. So which means definitely A and B are incorrect. Okay, now let us do the next one. Next one is, now I need to find what is the total current over here. Okay, the total current I is nothing but, okay, V divided by R total. What is V here? 4 volt. 4 volt. What is R total here? 2 ohms. We already simplified this and we have got this 2 ohms over here, which should be 2 amperes over here. So as a result of it, what is the power which is coming over here? When you say with the power, for example, when it comes, okay, before considering the power, let us consider, you can do it by 2 methods. Let me help you out with this way. Okay, a current of 2 amperes is flowing like this. When it comes here, you see there's a node. The resistance are equal. So this will be 1 ampere upwards, 1 ampere downwards, right? So this is what it splits into. Okay, this is my 2 ampere current. It splits into 1 ampere upwards, 1 ampere downwards. So as a result of it, if I ask you, what is the power dissipated across this? So what should I do? So across this one, if I want to find out, then the power dissipated should be equal to I squared multiplied by R. Which I? Is it 2 ampere or 1 ampere? It should be 1 ampere. Why not we consider 2 ampere? The reason is the total current, is the branch current. So therefore, this should be considered over here. So now let us substitute from here. So therefore, let us say I2 over here, I2 square. So thus I can now write P2 or the P branch current is nothing but equal to I2. What is I2? 1 ampere, 1 square multiplied by R, which is 2. 2, which should be equal to 2 watts. Thus, 2 watts of power is being dissipated here. So therefore, D should be your right answer. Is this clear? Okay, now let us move on to the next one. In the next question, 3 fixed charges plus Q, where is it? Plus Q, minus Q, where is plus Q? Plus Q is here, minus Q is here. Where is minus Q? It's in the form of an equilateral triangle. Okay, so this is plus Q, this is minus Q, this is minus 2Q. Okay, what is the resultant force on an electron at the center of the triangle? The center of the triangle. Let me join this first. So this is my equilateral triangle. Right, this is my equilateral triangle. Now, what is the resultant force? See, he's not asking you to find out what is the magnitude of it. He's just asking you to find out the direction of it. Okay, see, there are directions given A, B, C, and D like this. What is the resultant force on an electron at the center of the triangle? Center of the triangle in an equilateral triangle. It's an equilateral triangle. So, what are the types of centers you have studied? You have studied about centroid. Okay, you have also studied about in center, X center, and so on. In an equilateral triangle, all the centers will coincide each other. So towards it, what we do is let us take up the centroid part first. So let us take the center of this side, draw a line which joins the vertex here. Then this line will join this point. And with respect to this, which one is center? This is the center. So it will join like this over here. It will join like this over here. He's asking you to find out at the point P. Okay, maybe if I draw a line here, at the point P, what is the net electric field? Now at point P, what will happen? How do I find out the net electric field? So what I should do is, okay, net electric field, net force, resultant force. Okay, resultant force on an electron. On an electron at the center of the triangle. Yes. Okay. So if I keep an electron here, where will this electron move? Resultant force. That's what has been asked. Now, what will happen to this electron? This electron will be attracted by this plus Q charge, like this. It will move in this direction. This electron will be repelled by this minus 2Q charge, because minus 2Q, right? It will try to repel it like this. Then this electron, there is one more electron here. Now this will try to repel it like this over here. See, what are the forces I have? One force is like this, one force is like this, the other force is like this. Now, where should the resultant force be? The resultant force should be in this direction, right? It should be in this direction. Okay, either it should be like this. So therefore, now which of these arrows would coincide properly? See, definitely it is not A. Okay, and definitely it is not D. Now it could either be B or it could be C. Okay, that is what we need to look at. Now let us understand once again. Okay, so towards it. Now, if I put an electron here, this, he says there's an electron here also. Okay, so therefore, this electron will repel it like this. So therefore, this is E minus. So E minus, now you see, if this is your centroid, then what will happen? This will be in the ratio of 2:1 here. This would be in the ratio of 2:1 here. And this would be in the ratio of 2:1 here. Okay, so if I consider this as my X, then this will be X once again. 2x, 1x, 2x, 1x. Okay, that's what we have. So therefore, the force due to the minus 2q in this direction, okay, would be equal to K E minus 2E divided by 4x squared. Okay, along this direction. Then the force due to this electron, okay, in the upward direction should be K, then minus E divided by, once again, this is 2x, 4x square. Now, due to this direction, which direction is this? Plus q and minus q. So this would be, once again, k e, because plus e, into minus e divided by 4x square. Okay, that's what we have. Now you notice that this k e square by 4x square is common everywhere. Okay, so therefore I can now say this could be something like f, for example. This could also be f over here. And this could be 2 times k e square divided by 4x square, which would be 2 times f over here. So what will happen now? The diagram now looks like this. This is one line f. This is another line f. And the last line, this is 2 times f. See, I have simplified this one directly into something like this. So as a result of this, now when I say this f, and this f over here, so where will the resultant force be? The resultant force will be inclined in this direction, right? Okay, so because if I have a force A like this, if I have a force B like this, see the length of B is more than A, the resultant would be towards B like this, right? Now looking at this here, so definitely you have B and C was a confusion. So either it could be B or C. See, C is more directed towards this way. Okay, it is like this one. Okay, so definitely it is not this one. So it should be B. So the answer is B here. Okay, now let us move on to the next one. The graph shows the variation of current I in a device with potential difference V across it. What is the resistance of the device at point P? Resistance. Drop a perpendicular here, drop a parallel over here. Now, what is the voltage at point P? Point P, it is nothing but 20 volts. What is the current here? 2 amperes. So what should be your resistance? 20 volt divided by 2 amperes, which should be equal to 10 volts. So the answer should be 10 volts. Simple problem. Then, next. A resistor, a cylindrical resistor of length L is made from a metal of mass M. You have a cylindrical resistor. Cylindrical resistor of length L. Of length L is made of metal of mass M. It has a resistance R. 2 resistors, each of length 2L and mass M by 2. And you see, you have learned resistance. Okay, resistance in terms of L and A only by using the equation R equal to rho L divided by A. But suddenly you have put a mass over here. Okay, so therefore now we have to be very careful. Okay, how to convert or how to mention this mass in terms of length and area. That's what we need to do. Now towards it, this is length here, and this is my area of cross section. Okay, and then what we can do is we can now write, we can relate these two by using the equation density is equal to mass divided by volume, which should be mass divided by length into area. Okay, thus the mass can be directly written as rho into L into A. Okay, keep this in mind. Now let us read the problem. You have one resistor which is made like this, 2 resistors each of length 2L. Okay, so you have 2 resistors. You have 2 resistors of length 2L and mass M by 2. Mass M by 2 are created from the same volume of metal. Oh, I made a mistake here. Okay, are made up from the same volume of metal, which means same volume. Okay, then what is the resistance of the 2 resistors connected in parallel? If you connect these two in parallel, R1 and R2, what would be the total resistance? Now let us read it. It has a resistance R. When you say a resistance which has is given by rho L divided by A. Okay, what is rho? Specific resistance. It is not density. Okay, don't get confused. Specific resistance. Okay, of length 2L, and mass M by 2. Okay, and mass M by 2. See, if I say if a resistor has a resistance R, then it has a mass M. But if the mass is hard, okay, but the same volume is being used, which means what? The density is differing. That's what you need to know here. Okay, so density is different. See, two resistors, each of length 2L and mass m/2 are created from the same volume of the metal. Is using the same volume of the metal. Okay, what is the resistance of the two resistors when connected in parallel? So how do we do it? That is what we need to look into. Okay, let me re-begin. I missed a point somewhere. Okay, fine now. Now, according to the problem, the mass m is equal to density multiplied by length multiplied by area. This has been known to us. This has been given to us. Now what we do is, what does it say? It says that two resistors, each of length 2L, mass m/2 are created from the same volume of the metal. Now what is happening here? You have created two resistors, each of mass m/2, okay, and then created in such a way that they are from the same volume, okay, which means what? Now you will write the length is 2L, and the volume, what is volume over here? Volume should be now A/4. Why is it A/4? Why is it A/4? What is your answer here? It should be, just give me a moment. Okay, seems that the previous methods were a bit complicated. So I just tried to do something more easier. Okay, let us do this once again. See, it says there are two resistors made out of each of length 2L and mass m/2 are then created from the same volume of metal. The same volume of metal, which means what? If we have a length L and area A, then we can now say that L into A, m divided by L into A will be equal to density. Our mass should be equal to LA into rho. This is what we have. Now, what does it say? Once again, it says that created from the same volume of the metal, which means now the length is increased. And the length is increased, the area should decrease. But we need to find what is it, such that the same volume has been used. 2L into A2 should be equal to L into A. So density remains a constant. So what we do is we remove this, and thus you get A2 is equal to A/2. That's what we get. Now, what all we have now? We have L1 is equal to L, A1 is equal to A. Similarly, L2 is equal to 2L, A2 equal to A/2. Now, what do we need? We need R dash. Okay, the new resistance. See, we have not still completed the problem. Now we have got the resistance of only one of them. R dash should now be equal to rho times L dash divided by A dash. Okay, which is R maybe, which I can say this is rho times L2 divided by A2. Now let us substitute the values. Rho into what is L2? 2L. What is A2? A/2. So what is the answer here? 4 times rho L divided by A. This is the resistance, the new resistance. Now what is he asking here? Resistance of two resistors connected in parallel, which means this is your R dash, this is your new R dash. Connect both of them together and then find out what is the resultant resistance. Now if it was just rho L by A, if it was just rho L by A, the resistance was R. Since here it is 4 rho L by A, the resistance should be 4R. So thus, now instead of saying two resistance R dash and R dash parallel, now this can be said as 4R and 4R parallel to each other. 4R and 4R parallel to each other, which should be equal to 2R. So thus the answer here is B. Okay, then three resistors of resistance R are connected in parallel across a cell of EMF V that has a negligible resistance, internal resistance. What is the rate at which the cell supplies energy? Three resistors of resistance R. One resistor, second resistor, third resistor. All of them are connected to a battery like this. Connected to a battery like this. R. Now what is he asking here? What is the rate? Rate. Whenever we say a rate, which should be anything that you have here in the numerator, this should be divided by time. Now what is that you should have in numerator? At which the cell supplies energy. Energy should be in the numerator, which means you need to find energy divided by time for the full circuit. Now what is energy? Energy divided by time. Energy by time is nothing but power. Okay, is the power over here. Now what should we do here? Now what we should do is, now we need to find out that what is the total current drawn by the battery Okay, and if V is the potential difference, we have to just substitute V into I. Power is equal to V into I. You can do it like this. Sorry, V into I. Sorry. V into I. You can do it like this. But I had already shown you that power can be calculated in two more methods. The first method is V squared by R. The second method is I squared into R. The last method is V into I. But look at the options here. Every option has an R over here. Okay. None of them have either an I value or V into I method here. So which means he's only going to use this value here, nothing else. So what should I do? Now what I should do is take this circuit, simplify it. How do I simplify? 3 resistors in parallel. If I take the total resistance, it will be 1 by Rp will be equal to 1 by R plus 1 by R plus 1 by R, which should be equal to 3 by R. Thus Rp is equal to R by 3. This we have got. Which means the circuit, this complete circuit can now be written as one resistor like this, one power supply like this. And this should be called as Rp here. Now I am asking you, what is the power supplied by this? Okay, power supplied by this should be equal to V square divided by Rp, which should be V square divided by R by 3, which should be 3V square divided by R. Which one is the right option here? D is the right option, 3V square by R. Okay, now let us move on to the next one. You have 3 charges, plus 3 coulomb, minus 4 coulomb, and plus 3 coulomb. Okay, so the distances are given over here. What is the magnitude of the electric field sent at point P? Which is point P? Point P is here. He's asking you now the magnitude of the electric field sent. Now what can happen at point P? Point P, this will experience an outward electric field due to this plus 3 charge. So it is outwards like this. And due to this charge, it will be an inward like this. Now we need to calculate what is E1, what is E2, and then we need to subtract each other. Why subtract? Because you see, they are in opposite directions. Okay, now let us find out E1. E1 should now be K. This is Q. K into 3 divided by distance, x square. Direction like this. Then what is E2? E2 is nothing but K multiplied by charge, source charge. Which is source charge? This is source charge, which should be 4. I'm taking only the magnitude. Okay, I'm not taking anything else. I'm just taking magnitude 4 divided by total distance, because I have to take from here to here, which should be x plus x, which should be 2xd whole square, which should now be equal to 4k divided by 4x square, which should now be equal to k divided by x square. Now what is the direction? This direction. Okay. Now what should I have? I should now find out what is the resultant electric field of this. The resultant electric field E total is now nothing but equal to 3k by x square minus k by x square. Why should I put minus k here? Now you note that here that this is in this direction as compared to this. Okay, so this is larger vector. Okay, it is like writing one big vector you have and another small vector you have. Okay, so this big vector is 3k by x square, and this small vector is like this in this direction. So that's what you have here. 3k minus k should be 2k divided by x square. Okay, this is what you should have. Now let us simplify this. 2 into, what is k value? 1 by 4 pi epsilon naught into x square. So therefore, this x square should come downwards. X square should come downwards. So which should now be equal to, so 2 1s are 2 2s are, which should be 1 by 2 pi epsilon naught x square. Which option is this? Option B. Okay. Now let us move on to the next one. What is the ratio of the, what is the definition of the electric current? Definition of the electric current. The ratio of potential difference across a component to the resistance of the component, one of them. Then the power delivered by a battery per unit potential difference. Let us see this one here. Power delivered per unit potential difference. Definitely not, because you know work done is equal to Q into V. Now if it is power, then this will be divided by time, which means power should be equal to work done by time. So definitely this formula is incorrect. So you cannot have this one here. I hope you are getting this. Okay, this should be QV divided by T over here. Q by T will be equal to I into V. That's what we get. Okay. So what is V here? Potential difference. So therefore, this is not the right one. The rate of flow of electric charge. Rate of flow of electric charge, which should be delta Q divided by delta T. I didn't write for this one, right? The ratio of potential difference across a component. Potential difference across a component to the resistance of the component. Okay. What is delta V by delta R? Which should be I. Okay. V by R, by Ohm's law, V by R. Okay. But usually there are some situations where Ohm's law should not be applied. I also taught you that. So therefore, this also cannot be the right answer. Though mathematically you will be able to do it, but in certain circumstances, generally, you will not be able to apply Ohm's law. So this cannot be an universal definition. Then the energy per unit charge dissipated in the power supply. Energy per unit charge. Energy per unit charge. I'll write down as work done. Work done per unit charge. What is work done per unit charge? See here, work done divided by charge is nothing but potential difference over here. So therefore, this is also another right one. The only correct answer is C here. The rate of flow of electric charge is what you have learned when you also learn about electric current. Okay, so C is the right answer. So remember, most of you, okay, will write this as your answer, which is incorrect. Then next, 4 resistors are connected in series as shown figure. What is the total resistance between X and Y? What is the total resistance between X and Y? So how do I simplify this? Now you see, these two are in parallel. I already told you, you should first simplify the parallel ones. Simplify this one first. So what is the simplification of this? Let me write down the circuit. This would now be equal to, this is your point X. This is your 2 ohm. Now if I simplify this, let me write this as some RP. I do not know what is this value, which we have to calculate. And then once again, I have this 6 ohm, like this over here. Now let us calculate the value of RP. I'll do it here. 1 by RP is equal to 1 by 8 plus 1 by 8, which should be 2 by 8, which should be 1 by 4. So RP should be equal to 4 ohms. So I already got the value here. This is 4 ohms. Next, what should I do? What should I do? See here, it is a, once again, it's not a series or a parallel circuit. It is a series plus parallel. So I will join these two once again, which will now be equal to 6 ohms over here. And once again, you get a 6 ohm over here. Once again, we will write this as X and Y here. X and Y there. Okay. And thus what will happen? Here are 2 resistors in parallel. So what is the effective resistance? 1 by RP once again is 1 by 6 plus 1 by 6, which should be equal to 2 by 6, which should be equal to 1 by 3. Then what is your value of RP in that case? The value of RP should be, equal to 3 ohms. So the answer is 3 ohms. Okay. Then always remember, whenever given a complex circuit, you should first simplify the innermost branch. Innermost branch is nothing but your parallel resistance branches. Okay. Then now let us look at a few structured questions also. A heater in an electric cable has a power of 8.5 kilowatt. P is given to you. Is connected to a voltage supply. V is given to you. The moment P and V are given to you, you can find out current. Why do I say this? I have not read the full problem. Okay. Remember, in electricity, what is important is formulas. Okay. Concept is good. Okay. But at the same time, you should know which formula to be employed where. And in order to do that, you should have all the formula in your hand tips. Okay. If given these 2 inputs, you can find out the value of I. It is connected to an electrical supply by a copper cable. Okay. Following data is available. What are all the data available here? Length is given. Area is given. Resistivity is given. Now you see, when I say rho, L and A, what do you find out from here? You can find out the resistance. Right. Calculate the current in the copper cable. Very easy. So you need to just find the value of I, which should be equal to power divided by voltage. Why power divided by voltage? Because we know P is equal to V into I. Using this formula, I got I equal to P by V. So what is P? 8.5 kilowatt. So 8.5 into 10 cube. Kilo means 10 cube divided by 240, which would be 8,500 divided by 240. So let us find out what is the value now. The value should be Just a minute. Let me just find out what is that value. This should be 850 divided by 24, which is 35.4. So the answer here should be 35.41 amperes is the answer. Then calculate the resistance of the cable. Resistance R. Now what you should do, use it using this method. Okay, don't use P R equal to V by I. Okay, because the value of V, though it is given, sometimes it might change. So it is better that don't use that. You can use this one here. It should be rho L divided by A, which should be 1.7 into 10 power minus 8 multiplied by 10 divided by 6 millimeters square. 10 power minus 3 the whole square, which should be 170 into 10 power minus 8 divided by 6 multiplied by 10 power minus 6, right? And now this should be, now let us calculate that value also. How much do I get it now? This should be 170 divided by 6 is equal to 28.33 into 10 to the power of minus 8 plus 6 becomes minus 2. Unit is ohms, which would be 0.282.